Welcome to Chapter 8 of the Pre-Calculus course. Chapter 8 is about the properties of combined sinusoids, meaning that there are two sinusoidal functions combined together and that form the combined sinusoids. So when two vehicles are going nearly the same speed on the highway, the combined sound of their engines sometimes seems to pulsate. The same thing happens when two airplane engines are going at slightly different speeds. This phenomenon is called beats, okay, like for example on the piano. So using the concept of beats, a vibrato sound can be generated on a piano by turning two strings for the same note at slightly different frequencies. In this chapter, you will learn about combinations of sinusoids so you can analyze this harmonic phenomenon. So let's go to lesson 8-1. 8-1 is an introduction to combination of sinusoids. And in this lesson, we are to investigate graphs formed by sums of sines and cosines. So how does the sum of a sine function and a cosine function form? How does it go? I mean, if you add the sine and cosine function, what difference does it make to the original functions? So you have a preview of the graph of the sum of the sine and cosine. Well, initially, you can see here that the dashed line here with smaller dashes, okay, is the graph of the parent cosine function, y is equal to cosine of x. While the second dashed line here, which has the thicker and the longer dashes, is actually the graph of the parent sine x. While the red or the highlighted dash here, which appears in red, is the sum of these two trigonometric functions, two sinusoidal functions. So let's try to graph 3 cosine theta plus 4 cosine theta. And how do we get the graph of this function? First, we have to get at least values for this. But before we proceed here, let us first get the graph of the sine, the sum of sine and cosine. So let's start with the parent functions. Y is equal to y1 is equal to cosine theta. y2 is equal to sine theta, and let's call y3 is equal to sine theta plus cosine theta. Okay, so we will have to have the aid of a table, and let's have divisions of 3 columns. Okay, these columns must contain the theta and the value of the sine and cosine. So let's select up to 2 revolutions, or up to 720 degrees, or up to 2 pi in radians. Okay, so I think this is enough. Now let's say this is our theta values. This column here, first column, contains our theta values, and the next column would be our y is equal to cosine theta, so y1, and this is y2, and we need another for the y3, the combination of the sinusoids. Okay, we just need the horizontal lines to divide the column. Okay, so we are completing these strips, the cells. that contain the values of the parent cosine function, the sine function, and the combined sinusoids. So this is y3. Okay, let's start theta as 0, and then 90, and then 180, and then 270, 360. For 360 we will have 450, 540, 630, and 720 degrees to complete the second set of revolution. Okay. What is cosine of 0? That's 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. For y2, or the sine theta, it would start with 0, 1, 0, negative 1, and then 360, we have 0, 1, 0, negative 1, 0. So when we add this 2, we will get 1 plus 0 is 1, and then we will have 1, negative 1, negative 1, 1, 1, negative 1, negative 1, 1. So all are 1. Okay? So we can see that if we add y1 and y2 together, now they form, for the parent functions, they form the sums of 1 and negative 1. So this time we are going to insert the specific angles such as 30 degrees and 45 degrees. So that means that we have to insert another column here. This is for theta, y1, y2, and y3. Okay, let's insert the values of theta, which are in between these intervals, 0, 90, 180, etc. Okay? So let's start with theta. And this is y2. y1, that's y1. This is y2, and this would be y3. So we'll start theta as, or we'll actually insert, okay, as 30 degrees, 45, 60, so after 60 we have 90, after 90 we have 120, 135, 150, okay, then after 150 we will have 180, and then after 180 we have 210, 225, and 240 degrees. Okay, so let's try to look for the values here. y1 in this case is sine or cosine of 30, that would be square root of 3 over 2, and y2 is 1/2, so that would be square root of 3 plus 1 over 2, or in calculator form that would be 30 sine plus 30 cosine equals, that would be 1.367. Okay, or 1.366 instead. When it's 45, we have square root of 2 over 2. And the same is true with cosine or sine of 45, square root of 2 over 2. So we have 2 square root of 2 over 2, or the square root of 2. And what is square root of 2? So 2 square root is 1.414. Okay, these are approximations. For cosine 60 is 1/2 square root of 3 over 2, and this one will be the same. So we have 1.366, and 120, for 120 that would be 120 sine or cosine plus 120 sine is equal to 0.366. Okay, why? Because our cosine is negative and our sine is positive. So we will have negative square root of 3 over 2, and then 1/2. That will give us a value which is 0.3. Is it that one? Let us see again. 120 cosine. That's negative 1/2. Sorry, not negative square root of 3 over 2. So this is negative 1/2, and this will be square root of 3 over 2. So that will give us a value which is equal to 0.366. 135, that's still on the second quadrant. So our y value is positive and our y2 is negative. So y1 is negative and y2 is positive. Okay, so in that case we have negative for y1 square root of 2 over 2, and this is 0, or this is square root of 2 over 2. So we will have a sum of 0. Okay, and at 150 degrees that would be 150 degrees, that would be in the second quadrant again, and that's a reference angle of 30 degrees. So that would be square root of 3 over 2. For cosine it's negative, and this is 1/2. So that means that we have 3 square root minus 3 square root minus 1 equals divided by 2. That would give us 0.366. It's negative 0.366. Okay, so 210, that would be on the third quadrant. So that's the reference angle is 30 degrees. So we have both here are negative. So we will have negative 1.366. On the third quadrant again, that's 225. That would be negative square root of 2 over 2. Negative square root of 2 over 2. So we will have negative 1.414. And 240, that would be a reference angle of 60. So 60 we have negative 1.366. Okay? Okay. So we are missing the other quadrant, the last quadrant. So let's write it here. The last set of the angles. And we would need 3 more angles. So we have here, here, and here, and here. Okay. This is for the theta, y1, y2, y3. Okay, so if our theta is, we're done with 240, so let's go to 300 instead, because 270 degrees plus 30, that would be 300, and 315 and 330 degrees. Okay, so 300, that would be 60 degrees, reference angle of 60 degrees from the horizontal. So this would have 60 here. So y1 is positive this time because it's on the fourth quadrant, so 1/2, and our sine would be negative because it's on the first quadrant. So we will have a value which is negative 0.366. Okay, and then after that 315 degrees we will have a value. This is 45 degrees, so it's in the fourth quadrant, negative square root of 2/2, and we have positive x and negative y, so this is square root of 2/2, this is negative square root of 2/2, so we will have a sum of 0. And for 330 degrees, that would give us, we will have a reference angle of 30, so that's square root of 3/2, and negative 1/2. This will give us positive 0.366. Okay, now we're done with the computations, so we could move this. So I have sketched the graphs of these parent functions and also the sum of these parent functions. So our y3, which is equal to sine theta or cosine theta plus sine theta, is in green. And take note that we have the highest point here at 1.414. And as you can see, it goes, so this is for one revolution, it goes from 1 to 1.366 and then going here. Okay, so it goes like this. So take note that when we get the sum of the parent functions, parent cosine and sine functions, they define a new critical point, which is way higher and way lower than when the individual functions are taken. So you could continue this up to 720 degrees and just draw another replica of this cycle, and that will be the one for 360 degrees up to 720 degrees. So this is introducing the sum of two functions, especially sine and cosine. So this is what we call combined sinusoids. Okay.